Hello, everyone. Thank you for joining us. We'll go ahead and get started. I'm going to introduce our speaker today, Ben Carr. Um, he worked as an account manager for Swagelok from 96 to 2002 and returned as the regional field engineer in 2018. The 16 years between the roles at Swagelok, Ben was the director of the STEM Academy at a local high school and taught AP Physics, CAD, and a variety of math classes. Since his return, Ben has been working with our customers, providing technical support, product selection, and field evaluation services. He is an expert in mechanical seals and will be uh, giving a presentation on our best practices, and we'll be able to answer any questions along the way.
Thank you, Brian. So as he mentioned, we'll be answering questions along the way. If you'll use the Q&A feature, and that will allow us to get some feedback. And if you feel free to put that in at any time. The presentation should take about 30 minutes or so, and that leaves us some time for some question and answer at the end as well. So if you think of something, go ahead and put it in the Q&A. We'll pause occasionally for that, and Brian will bring that to my attention, and we'll get those questions answered for you. So today we'll be talking about mechanical seal support system best practices. And as we take a look at that, I want to be clear that with Swagelok Seal Support Systems, our offerings are based on an API 682 plan, but they are fully customizable to your needs. So we'll take a look at some of those things. So just for today's agenda real quick, we'll talk about a brief history of objectives for seal support systems, the piping or tubing standards, designing seal support systems for reliability by reducing leak points, making sure that it's easy for your operators to use and maintain, and then also designing seal support systems for safety. So we'll be covering a few of those items in detail as well. So pump seal standards, you may be familiar with some of them, API 682, ASME ANSI B73.1, and then the ISO 21049. If you can, use the raise of hands feature just to say whether you guys are using any specific standards within your plant, any of those three standards. So nobody has any standards within your plant that you're using specifically. You're just working with the seal manufacturer to determine the components you need, I'm assuming then. So Swagelok used the API 682 in order to just standardize our designs. But again, they are fully customizable. You are not required to adhere to those. The API 682 is a best practices list. It is not a code like the ASME B31.3. In fact, the ANSI and API standards or API plans cross over pretty easily. You may see like, oh, I need a plan 32 from API. Well, the ANSI plan may just be a 7332. And so those are going to be very similar in how they're called out and the features that you should have within each one of them. In API 682, the two sections that kind of deal with seal support are the Section 8 for the accessories and then the Annex G for the standard piping plans and auxiliary hardware. So again, the main reason we pick this is it's a global standard, one that's recognized worldwide. It is best practices for safety, reliability, and ease of maintenance. And so that's what we're striving to achieve with all of our systems, whether they're seal support or not. API refers to piping plans, but piping plans can include threaded pipe, welded pipe, or tubing. And tubing is becoming more widely used because of the reduction in leak points. We'll discuss that in more detail, as well as ease of installation and maintenance. So if you were to look at the API standard, it does list out pipe from 1/2 inch all the way up to 4 inch with the minimum schedule that you should use. Because the piping systems are often exposed, you'll see that generally you're using a pretty heavy wall pipe, and the same thing goes for the tubing. So in the tubing specification that they show, we're using heavier wall tubing here in the 065, 095, and 109 wall to make sure that those systems do not become damaged or have a failure because of somebody hitting those systems, either by moving product around or even just stepping or standing on them. The table doesn't list the 1/4 inch and 3/8 tubing, but often those have very low pressure and can be used with traditional tubing wall thicknesses as well. We are seeing some usage in the above 1-inch size, but those pumps are not as commonplace in our area of service. So here we have a bearing lubrication and flush seal plan on a pipeline pump. The customer had quite a few of these across their pipeline systems. They were all pretty similar. In order to service the bearing housing that's shown there with the red arrow in the top right, they had to disassemble much of the system. You can see that it has lots of threaded connections, lots of union ball joints, and this service took up to 40 hours to do one of these pumps and service it correctly. They had to repaint the system because it was carbon steel every time, at least all the joints where they took it apart. So it was very labor intensive and difficult to maintain. So Swagelok, working with Swagelok, we helped them develop a tubing system. So this is that same pump system designed with bent tubing. And you can see just immediately that we've reduced the number of leak points. We've made it much easier to service by, if they had to get to this bearing housing down here, they could disconnect the fitting here at this end connection and then the one on the opposite side as well. And they would be able to remove that bearing housing. We also designed the system around the center line of the pump to reduce excess vibration through the system, making it more reliable and, like I said, easier to maintain. And then lastly, because we replaced it with stainless steel, they no longer had to paint the system. So what this resulted in for the customers, they were able to do 3 or 4 of these systems in a week instead of just 1 per week. So again, just simplifying the system, making sure that it's serviceable, making sure that it's maintainable, and doing so with bent tubing and still maintaining the reliability for long-term usage. Any questions so far? I'll take the silence as a no.
There are no questions at this time.
Okay. All right. So again, API is a standard, not a code. It is trying to show that we design around standards throughout your plant, making it easy for your operators and maintenance personnel to know what's going on with the system, making it easy to do their job, and also to make sure that you have a proper PM schedule in place. So for like this plan 12 that we're looking at, we've showed the strainer and the orifice plate, and then going to the seal itself off your process line. There's no way to know about the health of that strainer, whether it's plugged or not. And so without a proper PM schedule, it might go too long and cause a seal failure. So one thing that we might want to look at is, while we're still trying to reduce leak points, we don't necessarily want to add in a bunch of components. We may need to add some instruments to allow us to actually get some good data on how this strainer is performing based on the cleanliness of this process, and then how the seal is performing. So often you might introduce some instrumentation. So here we see that same flush plan 12 with the strainer, and then we've added a pressure gauge before and after that strainer so that you can get a differential pressure across that strainer. And if you wanted to, this could even have a customized bypass line in it so that the strainer could be serviced while the system is online. And again, just to make it easier for you to maintain and lengthen your seal life. Now, you may say, well, now you've added in a bunch of leak points. And while that may be true, these instruments don't necessarily have to be permanently installed. They can be installed until you can collect enough data to make sure that you've got your PM schedule set. And once you have that, then you can take those systems out and standardize across your other pumps as well. And we'll take a look at what that looks like. But by use of tubing, this is really easy to add or remove components at any time. So here's an example of even a new install, and this actually became a bad actor pump in the long-term process. We'll take a couple of look at a couple of details on it. This actually has a Plan 11 and a Plan 51 installed on this, and you can see the Plan 11 down here with the flange connectors, as well as the Plan 52 with the seal pot, and 51 with the seal pot and the hose connections. So with the Plan 11, there's an orifice plate right here in between this flange, and there was no way for them to know whether that orifice had become blocked or had eroded to the point where it was allowing too much fluid flow in the system. And because this was all welded, and you can see that back here, there was no way to actually add or remove instrumentation without welding up the system again. And so, like I mentioned before, using tubing here, we can easily monitor that system by adding instrumentation. Also, Swagelok offers a flange with the orifice directly into it to a Swagelok tube fitting, so that makes it easy to install. The next thing we'll look at is where the Plan 51 actually connects the seal. And you can see there's a, right in the bottom, you can see there's a pipe nipple, a 45, a union, another connecting fitting, and then to the hose. So we've introduced 1, 2, 3, 4, 5, 6 potential leak points in this system, and there are ways we can eliminate some of those leak points and still give your operators access and ease of maintenance. And then lastly is the most obvious, and that's that kinked hose up there at the top. Really, hose is not recommended for use with mechanical seals because it's not a matter of if the hose will fail, it's when the hose will fail. And if it fails, obviously while the system is online, you could lose or damage the seal for that particular pump. So hose is nice because it's easy to install and easy to remove, but we can design systems in such a way with tubing, which is much more reliable, that is just as easy to install and just as easy to maintain without having to take apart numerous threaded connections. All right, so we mentioned eliminating leak points. And one way we can do that, as in the previous picture, we see multiple connections to make the transition from the pump seal through the housing and out to the tubing. You can see that here again with a close nipple, a union, and then another male connector. Swagelok has developed a extended male connector. These are available in various lengths to be able to thread into the seal and get you past your housing of the outside of the protecting of the seal pump. This allows you to go directly to tubing. And again, if we design this well, this is easy to remove and maintain.
We do have a question though from Thomas Silva.
Okay.
Would that be a stainless steel or the stainless threaded connection on?
They are stainless threaded connections on those. So that way you can use stainless steel tubing throughout and not required to paint or try and maintain that if you got corrosive materials.
Does that help, Thomas?
I'll try.
It does help. He's concerned a little bit about galling there, Ben.
Okay, and we have some products that will help with that. We can use obviously Teflon tape. We also can use silver goop or some other thread lubricants for installing those as well, or our SWAC products.
Thanks. And it seems like everyone is okay with the audio. It does crack a little bit, but everyone's able to follow along fairly well. So
okay.
We have another question from Guy Lowry. He says, do the stainless steel extended fittings come in 1/2 inch and 3/4?
They come in 1/2 inch and 3/4, as well as I think there are a couple of other sizes available as well in the connections. I'd have to look that up specifically. I'm sorry, I don't have that in front of me at the moment. All right, another way to address leak points as you're adding instrumentation. In this example, we're looking at a thermal well. This thermal well was created, you can see here, with 5 different welds as we go from the 1/2 inch through the reducer to the 3/4 inch T, and then to the MPT outlet on the T there. While the leak points are critical, we really only have 2 leak points because with a welded system we should be pretty safe. But you can see the 2 threaded connections where the threaded into the T with the thermal well, and then where the thermometer threads into the thermal well itself. And the real hazard here, or the potential leak point here that really is of concern, is if the maintenance personnel were coming by and trying to change this while the system was online, and tried to unthread the thermometer without a backup wrench on the thermal well, or maybe they accidentally thought the thermal well was the thermometer threading, they could actually unscrew this while the system was online. That risks obviously damage to your pump, as well as exposure to the operator of system media. So one way we can address this is by using a thermal well T. And thermal well T is designed so that the thermal well itself is welded into the T. You can see that here in the branch T as well as in the run T. You can see that both of those have the thermal well welded in, so that allows the service and maintenance and calibration of the thermometer while the system is still online. And these are available as stock items as well from Swagelok. We want our instruments placed so that they're easy to read. It doesn't give us any information if they're positioned in a way that nobody looks at them. They also should be easy to isolate, so that they can be replaced if necessary, calibrated if necessary. And you can see in the little PNID symbol up there where we have a block valve and a bleed valve for these systems. That way it can be depressurized if they need to be removed from the system. Another really good reason for having that block and bleed valve there is there's really no reason for the gauge itself to be pressurized unless there's somebody standing there to read it. So you can actually isolate that gauge from the system when nobody's there, and it increases the life of your gauge as well. So a really good idea to add in those block and bleed systems to allow your valves to be serviced and isolated. And as we talk about designing for reliability a little bit more, oftentimes it's good to have that online data. So you may want to use transmitters for both temperature and pressure. That way you get real-time data from your seal about its health, about the fluid that's going through it. And this can give you some idea on how to maintain and prevent damage at your seal prematurely. So both of these systems, the Plan 76 and the Plan 74, both have different types of transmitters. And in some cases, pressure switch is sufficient. But again, if you're trying to really get that real-time data, it's good to have those transmitters. The other thing that you might notice here is these pressure gauges are mounted in both systems in a way that would be very difficult to remove them from the system if they did have to be replaced or taken out for calibration. Because this threaded joint here would not allow it to spin in reference to the other materials there. So one way you can address that is with a tube adapter style gauge where it fits into the tube fitting, and the tube fitting itself becomes a union, and the gauge can be lifted straight out the top. Again, just trying to design for ease of maintenance, reliability of the system in general, not just your seal, but even the tube support system or seal support system as well. Oftentimes, your seal manufacturer will give you kind of a basic list of items that you want to have in your system, or the minimum requirements, but they leave it up to the installer and or the operator to determine the other components to be added to the system. So one consideration is vents and drains. So in a system that may be a liquid system for the seal support, it's important to have some high point vents to allow any gases out of the system so we don't end up with trapped air in the mechanical seal itself, creating damage. If it's a gas seal, you may want to have a drain point, a low point drain, to allow condensate or other vapors that might have condensed inside that system. Or if it's a liquid system, allowing it to be drained before the operator breaks the system and gives them a controlled way to drain out the tubing before they disconnect the seal. Any questions about reliability, instrumentation, anything like that?
Don't see any on reliability and instrumentation, but back a little bit to the extended male connectors. There was a question about what type of different high temperature alloys may be available for those.
We do offer those in some of the duplex materials. I can get you some more information regarding the other materials if you will email me after this presentation. Anything else?
That's it so far.
Okay. All right, well, let's talk a little bit about safety. Here is a image, the PNID first, of what the seal manufacturer gave to them as far as required components or suggested components for this Plan 32, and then you see the actual Plan 32 that was built in the field. So we can see that there's an isolation valve, a strainer, the flow instrumentation which will be required, a needle valve to control that flow or adjust that flow, pressure indicator, and then a pressure transmitter as well, and then a check valve. So they've got most of those components in there, but you can see as it comes in, it comes down through this hose, makes a hard 180 through the flow meter or flow indicator, up through the strainer, and then through the check valve and to a ball valve that they're using for flow control. And a ball valve really isn't meant for flow control. Ball valve is great for isolation, but really shouldn't be throttled as it can erode the seats and also the ball itself as materials go through it. And then in addition to that, somebody who's not familiar with the process might see that as partially open and go, oh, that needs to be open, and open it fully, and result in damage to your seal as well. So we can design better than this. This also, from a safety standpoint, the operator may not be able to really easily read this, so either they neglect to read it or it puts them in a bad position, maybe next to hot processes, trying to get a good read on that flow. So we can we can design this as a panel system. So this is that same Plan 32, only put up on a panel where it's at eye level. Again, making it easy for system operators to observe whether the seal is working correctly. Here we have isolation valves before and after the strainer. The bypass loop can be added to that. Again, this is the Swagelok standard offering. We can customize this in any way for you. But isolation valves allowing for the strainer to be cleaned out. And again, like I said, a bypass loop could be added to that in order to do it while it's online. You have your flow indicator. You have a needle valve to control the flow. And then you have your isolation valves as well on your pressure gauge, along with the thermal well T. So again, this would be a standard style offering from Swagelok according to API Plan 32, but it is flexible and allows you to customize as needed. For panels, we also want to make sure that we have it labeled for safety, and there's some notes on this one that are Sharpie written in. You can see some of them are starting to fade, but it is good that they have those notes there, but we can do a little bit better than that as well. This is actually a Plan 74, and we'll take a look at Swagelok's solution to something similar. So this is our API Plan 72, Plan 76 on a single panel. This has been vinyl wrap that allows us to put lots of information on there for you as needed. And it's completely customizable. We've tested these vinyl wraps. They're similar to the vinyl wrap that you would see on a car. They've been tested for 1,200 hours in a salt spray lab, also with UV, and it holds up and with no degradation to the system or to the vinyl wrap itself. In this particular case, there were actually two different materials used. So the Plan 72 was built out of 316 stainless steel, and the Plan 76 was built out of Monel. So by using two different colors, we were able to indicate to maintenance personnel if they had to replace any parts to make sure they were using the correct materials to prevent chemical corrosion on that. Also, with that, we put in there set points for instruments. So that labeling indicates to whoever might see that where those should be reading, and they can then determine if there's a problem with the system or if it's been adjusted incorrectly. And then also more operator instructions for where the bypass valves go, what's for controlling our flow rate, things like the gas should be the first on and last off whenever service is done. So again, this is customizable to your needs, and it can be standardized across maybe all of your pumps of a particular design. Pause for some questions if there are any. Keep seeing something pop up on the corner of my screen. So.
Oh, that was me answering another question, Ben. The Plan 32 that we had in the example where the flow was coming down and then looping through the flow meter, there was a Y strainer installed, but it was installed vertically instead of horizontally. And there was a question about how that Y strainer. The next slide. Yeah, there you go. Yeah, that Y strainer is essentially vertical, so it's it's not able to really strain out very well and filter.
Yeah, that's definitely another issue with this particular installation. So again, putting it all on a panel, we can control and prevent those kind of things.
Exactly, and you see that we have the Y strainer installed horizontally so that it can work efficiently in this setup.
Sure. Anything else while we're here?
Give a couple of seconds. There's nothing else.
Okay. Did I skip? No, that's where we were. All right, and lastly, we just talk about as we look at safety, protecting your operators, we want to fill seal pots from grade if possible. In this case, this was between 8 and 10 feet in the air, which made for a inefficient and unsafe refill. The arrow indicates where the actual filling port was. So it required the use of a ladder to fill the seal pot. The equipment had to be shut down and cooled. There was health and safety issues from exposure to hot and hazardous gases up to 300 psi and 350 degrees Fahrenheit in this particular case. So again, being on a ladder, opening the system and trying to fill that was becoming an issue for them. So Swagelok came in. We designed a system that could be filled from grade. You can kind of see that down here at the bottom. Operator standing on the floor. We gave them a pressure gauge so they could monitor the pressure in the seal pot. There's a check valve in the system that allows them to do it while it's online without risk of exposure to the fluids. And our standard offering looks something like this with a quick connect down here at the bottom, isolation valve, check valve, and then a vent valve for further maintenance that may be needed in the future. So that, again, allows your operator to stay on the ground. They can do it easily. It can be standardized across your plant. So there's not a need for different ways for filling each system. And again, trying to make it easy to maintain and reliable for your personnel and make your seals last longer. So with that, we'll wrap up. Like we mentioned, tubing offers advantages for seal support systems by allowing for ease of maintenance, reducing leak points. The material offerings give you corrosion resistance, putting things on a panel where it makes it easy for people to read, maintain, and operate. And then lastly, talking about filling seal pots from grade and standardizing your systems across your plant. And like I said, we've standardized Swagelok systems on the API 682, but even if your plant is not using API, these best practices go across the board and can be customized for your specific needs. So with that, we'll kind of wrap up and just open the floor for questions, comments.
And Ben, one that came in was back to the different alloys that the extended male connectors could be made of. I'm seeing that we've made them out of Monel before as well, but there was a question about Inconel. I don't see any history on it, but I believe that we likely could, machine one. We would just have to, I think, to your point, Evelyn, go through our custom solutions route and basically kind of make it or have one, specially made.
Yeah, I hadn't taken a large look at the materials for those at this time, but I have seen them in duplex and, like you said, Monel, but I'm not sure about Econel. But likely we could do it. Probably isn't the first time the factory's been asked for it.
Yeah, likely not.
Anything else?
I do not see anything else at this time. And Ben, we just got another question about seal pots. Question is, will we offer the seal pot as well, or just the connections? And things
Yes, no, we can offer the entire package with the seal pot as well as all the connections. We'll work with you to specify what you need, but yeah, we can definitely provide the whole system as a turnkey package.
Thank you very much. We have a question about the vinyl on the panels. With the vinyl on the panels, how best would changes be made to the labels if anything needed to be changed at a later date?
So if something needed to be changed out and instructions changed, that's a good question. We might have to just make some kind of vinyl sticker that would go over the top of that. I haven't had that question before.
Yeah, I agree. It may be a new vinyl sticker made of the same material or some kind of label to go over it.
Yeah. We could also laser etch some stainless steel tags that could be pop riveted in place. That would be another option.
I seeing some more questions pop in, or
No, it looks like we don't have any more questions at this time, but there seems to be a lot of folks that really enjoyed the presentation. Ben, I think you did a great job, and I think, like you said before, just let us know if you have any more questions, and please feel free to reach out for help.
all right. Thanks again for everybody being here. And again, feel free to email us your questions as they may come up at a later time as well.